In this section, we're going to go over complex numbers. So what I mean by complex numbers is there are non-real solutions, and they're also known as imaginary numbers. So let me go over what I mean by non-real solution. So before, we talk about square roots. So for example, if we do the square root of positive 16, the square root of it was positive and negative 4. So again, there were two solutions, a positive 4 and a negative 4. So therefore, these two, since you were able to do the square root of a positive 16, these are your two real solutions. So again, real, positive 4 and negative 4. So this is what happens when you get or doing a square root of a positive number. But here, if you were doing with square root of a negative 25, so again, doing a square root, you have to think about what two numbers that you can multiply, but again, they have to be the same. So let me write here, same. So right off the bat, you're probably thinking negative 5 and 5. But here's the situation. They're not the same. And the condition is it has to be the same. So okay, it can't be negative 5, 5. But what happens if you say, negative 5 or negative 5? Well, you gotta think about it. When you're multiplying with two negative numbers, negative 5 times negative 5, that's a positive 25. But we start off with negative 25. So that can't be the case. And we already know for sure a positive 5 times a positive 5 will give you a positive 25. So that can't be the case. Again, we have a square root of a negative number. So here we're going to have non-real solution because we're doing a square root of a negative number. So in order to simplify this, we have to use what we call imaginary numbers. So again, to review, when we're doing a square root of a positive number, we get two solutions that are both known as real solution. But when you're doing a square root, and again, this complex number, imaginary numbers, will apply to square roots. So when we're doing square roots of negative numbers, then you're going to have non-real solution, meaning we're going to have imaginary numbers. Now imaginary numbers, you've seen it before, and you probably can guess imaginary number stands or is used for I. So when you have just I, it just basically means the square root of negative 1. And then there's actually three more. So when it's I square, it basically means negative 1, the square root of negative 1 times the square root of negative 1, which is negative 1. When it's I to the third power, it's square root of negative 1 times square root of negative 1 times square root of negative 1. Now, based on I squared, we know that the square root of negative 1 times the square root of negative 1 is negative 1. And then times, well again, this negative 1 came from these two. And then I bring down the square root of negative 1, which is negative the square root of negative 1. So when it comes to imaginary numbers, we don't typically leave it as negative square root of negative 1. we know that the square root of negative 1 is just I, so we leave it as negative I. Now, the last one is I to the 4th power, which is the square root of negative 1 times the square root of negative 1 times the square root of negative 1 times the square root of negative 1. And you can see it multiply itself 4 times. So if we were to do this part by part, so these first two, when you multiply, that becomes a negative 1. And then the last two, the square root of negative 1 times the square root of negative 1 is negative 1. So negative 1 times negative 1 is a positive 1. So when it's I to the 4th power, it's a positive 1. So let's review. I means the square root of negative 1. I square equals to negative 1. Sorry, here's your square. And then I to the 3rd power is just negative I. And then I to the 4th power is positive 1. So those are the 4 imaginary numbers you have to remember when we're referring to complex numbers or imaginary numbers. So make sure you remember this when we're going to be working with simplifying radicals with negative numbers or imaginary numbers or non-real solution. So, how does this apply to simplifying radicals with negative numbers? Alright, let's start off with the first example. So, say we have the square root of negative 49. So again, we can't just do the square root of a negative number, because if you're doing square root, your first job is to look for a real solution. But in this case, we cannot. So therefore, we're going to be working with non-real solution or imaginary numbers. What we can do with the square root of negative 49 is you can break it down into two numbers. Two numbers that multiply to negative 49. Well, for sure, we can use negative 1 times 49. So again, negative 1 times 49 will give you negative 49. So we're going backwards, we're breaking it down. Since we are multiplying inside the square root, you can split it into two square roots. So negative 1 times the square root of 49. And we do this by parts. The first one, the square root of negative 1 is just simply I. And then the square root of 49 is just 7. Now, since we did the square root of 49, we're not going to include the positive and negative, not just yet. But again, let me explain. We did this parts by part, so easy to see, easy to follow through. Since it's multiplying, we broke it into two parts. Now you can see that the square root of negative 1 is I, and then over here the square root of 49 is 7. But again, when we're doing the square root of positive numbers, we have to include positive and negative. So I times positive negative 7 is positive negative 7I. So that's our answer. So let's do another example. So say you have the square root of negative 100. Now again, if you want to do this step by step so that it's easy to follow through and try not to make any easy mistakes, we're going to break negative 100 into two factors. So say I do a positive 100 times -1. And again, I can split that into two square roots. So the first one is square root of 100 times the square root of -1. Now I can do the square root of both of them. The first one, the square root of 100 is positive -10 times the square root of -1 is also known as I. And then positive -10 times I is just positive -10I. So that's our solution. So that's how you would simplify radicals with negative numbers inside. So again, the square root of a positive 49, you will have a positive -7. Same thing over here, the square root of positive 100, positive -10. But when there's a negative number inside the square root, you have to include the -1, which will switch out as I. Next, we're going to talk about what happens if you have a negative outside the square root. So for example, if you have a negative outside the square root and we're looking for the square root of -16, so that means again we're going to keep the negative, and then I'm going to break this -16 into two numbers. So 16 times -1, I break it into two factors, two square roots, so negative square root of 16 times the square root of -1. Now, since there's a negative outside the square root of positive 16, and again, we said that the square root of a positive number will be two solutions, but since there's a negative, we can't include the positive, so we're just going to keep it as negative. So, the square root of -16 will be just -4, and then the square root of -1 is just I, so the answer is -4I. So when there's a negative outside the square root, that means you only have one solution, which is just a negative number with I. So keep that in mind. If there's a negative outside the square root, then you're going to keep that negative to the final answer. So that's all you have to do with negative outside the square root.